our next speaker, I hope my slides are visible again.
Yeah, it's visible. Yeah.
Okay. So our next speaker is Nico Maas, who's actually he's working for the Deutsche Luft- und Raumfahrt Zentrum, right? As a ground controller, but and you're talking about push to deploy to Milljuuunen, millions of Raspberry Pi clients. But in this talk, you're here not as an employee of your company or as employee of Resin.io, but as an IT engineer and a Raspberry Pi geek. Is that correct, Mark?
Yeah. That's
Nico.
absolutely correct. I'm actually involved in a little bit of some community projects like the Pi and More, which is the kind of like the biggest Raspberry Pi jam we got here in Europe, which is actually taking place in Stuttgart at the University of Stuttgart next weekend. So so now on Saturday. It's a big free convention, so everyone who is interested in single board computers, Raspberry Pis and stuff like that can come in and join us. And yeah, I'm really interested in Docker and Raspberry Pi. So yeah, let's choose the thing that's between both of those. And that's kind of like resin or hybrid if you want.
Okay.
So, and
by the way, the Stuttgart stuff, can you send us the links and we'll post them up later? Yeah. Perfect. Yeah, with that, I think now that we're in a remote virtual meetup, we don't need to do a 5 minutes bio break. So if we can directly hand it over to Nico. Well, perfect. Thanks for being here. Let me stop my sharing. Share here. On. Where's that? And
okay, now I try.
Yeah. Okay. Cool. Yeah.
So I hope that works. So I will start my presentation now. If you have any questions, just ask. But I'm going to try to kind of like work around a little bit and kind of like start with directly try to start with a live demo, which hopefully will work. It could be that it breaks and everyone will be crying, and I hope it will work out, but we will see. And build upon the live demo a little bit later. So first thing, a little bit about myself. I'm a Master of Science in IT System Electronica. I'm working for the German Aerospace Corporation, so for the DLR, for the Columbus module of the ISS. And I'm not here for my company or Resin, but I'm here for my own self and my interest in single board computers and Docker. So if you want to kind of check out other slides and stuff like that, I normally post them on my website, on my weblog, nicomaas.de, and you can join on Twitter.
Just a moment, Nico. I can hear a lot of noise. I'm not sure if it's someone else, but if someone has the microphone open and I can see it, close it. I'm not sure if I'm the only one who's hearing that.
No, you're right, Adele. Please, everyone, mute your mics, please. Still there?
Still there.
Or maybe it's coming from your mic, Nico.
Please. I think you should have the button, right?
Okay, now it's better. Okay, Nico.
Okay, thank you very much. So, okay, it's coming again. After saying that, I think we just start. So, a little overview about the talk, and try to give a little introduction. Okay, that's a little bit interesting. Try to do an introduction to the whole topic, then talk a little bit about Resin.io, Resin OS, and Balena. These are the kind of like three components we have been talking about today. So, first thing about Resin. What is Resin, or what's the idea of Resin? Basically, the basic point of view we want to think about Resin is the basic idea of IoT devices in the internet. So basically, you having your Raspberry Pi or similar single board computer, and you're developing some kind of application for that, and you want to put it onto the net. Something like, let's say, some blinking lights, which we will have later here with some LEDs, and it does some really cool stuff, just like showing up if some people are coming in, or if you run out of milk, or stuff like that. And you want to kind of like deploy that to the net, but you want to do it in a kind of like secure way, because the problem is you have to provide updates, you want to have the connection to this thing, and you want to kind of like be able to control it. So basically, how does your net normally look? Yeah, your net is normally just a local network, which is kind of like easy because you're in the network. You can kind of like go every time to your device and maybe even unplug it if something goes wrong, or reflash it, have access to the SD card, no problem. If you scale up a little bit and you're kind of like placing your device in a remote location, you got a whole WAN between it. So basically you got problems with your providers, losing internet connection, stuff like that, blocked ports. So things start to get a little bit problematic. And if you're scaling that up even a little bit, so kind of like some kind of, you're doing that not for yourself and your corporation, but for others and providing it as a service, you got really complex kind of structures there. You got maybe some customers using your device behind corporate firewalls. You're having that in some kind of like insecure links or stuff like that. And basically stuff like that. Now we have 2 Raspberry Pis floating in space on board of the Columbus module, and they want to be provided with updates. So you kind of like get some really interesting stuff down there, and which can become kind of like tricky. And that's the thing where kind of like Resin starts. The basic idea is, how do I want to update my device securely, provision it with updates or new application, and try to, yeah, keep it working. So the basic idea normally is kind of like, okay, I try to make a VPN tunnel and just like throw stuff on it and it works. Not always. Same thing goes for reverse SSH or VGET, or trying to download my updates via some kind of cron jobs, checking them out from Git repos. The problem is, you can kind of like do this stuff very easily from your home and kind of like plug it together, and then something happens, something like to the outside because router or firewalls are blocking your connection. And yes, that's basically a thing Resin won't help you, because if you got no connection, you got no connection. We cannot make any magic happen. But if you have kind of like some temporary connection drops or transfer errors, where you basically corrupt your files or stuff like that, that's a thing where Resin can actually help, because normally you would just like download a binary chunk, maybe some kind of like new application file or stuff like that. And if this file becomes corrupted and your script restarts your device, it's basically, yeah, it's kind of like broken. You have to get down there again, reflash it, stuff like that. Or if your update script is corrupted, or the application itself, it contains errors and blocks your device because it keeps on crashing your device, then you actually get into a huge list of problems. So you have to be absolutely sure that everything's working at all time, and that's a thing you mostly cannot provide because things go wrong. So the basic idea is, okay, we think about what happens if things go wrong and how we deal with that. So Resin.io is kind of like basically the idea of software development deployment done right, or how they call it. So how does Resin solve the problem? The overview is kind of like really easy. The basic idea is putting everything you want to run into a Docker container and just ship it to the device, and everything will be fine. That's the basic idea, but it's not as easy as that it gets. So basically, a Resin consists, or Resin.io, which is kind of like the service you can actually use and get your application onto and get it working from there. Resin kind of like gives you kind of like a Git repo, where you can actually push up your Git source files, and it's then going to build a Docker container specific for your device. So basically, it contains Dockerfile templates for a lot of different SBCs. So we're not talking about Raspberry Pi only here, but also different kind of Samsung devices or other chips. So it's basically a really long list if you scroll it down. And these building pipelines specifically will be building your application for those kind of devices, and then ship them to a private Docker registry, which they hold on premises. And from that moment on, they have your application ready and can ship it. And that's going to be done via VPN, so that you're kind of like secure. And yeah, from that moment on, you basically got the stuff onto your device. but that's kind of like the easy thing. So what's really kind of like the nice thing about all that stuff, because CI pipelines, well, we know that stuff already. The good thing is actually the Resin OS, the operating system, which is running on here, which is based on Yocto. And it kind of like contains a little bit of, sweet sauce or secret sauce, if we can call it. It basically runs not only VPN agent, but it is for large parts of the OS are read-only. So the nice thing is, if your kind of like device crashes and your SD card normally would have the risk of becoming corrupt, this won't happen here. You got an update partition where you can kind of like do some kind of transactional update of the Resin OS itself. And if kind of like Resin would kind of like crash during the update, it would automatically fall back to the normal state, and you got your Resin OS running. If your container with your application would crash, it would just restart the container. And if kind of like the container, which was kind of like transferred via VPN, would run into errors, or the container would be kind of like corrupted or damaged, then it would just like re-download it and leave the normal container running as long until the download is completed successfully. So basically, with that in mind, they kind of like keep the device secure, so you get kind of like your updates via VPN, so your code is protected. You get actually you don't have the problem that if kind of like the connection drops or you get transmission errors, that your device kind of like falls down. And you actually have the possibility to remote control your device via Resin.io. So you can at all times kind of like check in, restart the device, push new code, erase the device, reset it, stuff like that. And that's all kind of like comes in Resin or Resin OS in different flavors. So basically, to see how that all works together.
So Nico, can I ask a question in between?
Sure.
So one of the questions I always had is, when you have a Raspberry Pi and you do not have the physical security, if somebody can tamper around with it, typically you talk about trusted computing chips and safe boot and so on. Is there something which Resin has with hardware attached, which kind of ensures that part of the path?
Yeah, definitely. Currently, that's not an option on Resin.io. Probably that's mostly because of the kind that Resin tries to kind of like capture as most devices as they can get. So probably that's a thing which could come, but the problem is I do not recall that more than the hardware random number generator the Raspberry Pi has on board, that it does not have any kind of like TPM or stuff like that included. So you would basically have to kind of like add the device, and especially I actually did that for a project. But the problem is, that it's kind of like another device which is added, which is kind of like really easily to sidechain attacks. So you can kind of like access I2C bus or stuff like that on a device because you just like glue it onto there and kind of like sniff the transmissions from there and stuff like that. So to make something really, really secure, you kind of like would have to include the chips kind of like on a system on a chip level, or kind of like try to get it as close as possible to the device. So that's something which should be done at the device manufacturer level already. And
but the principle is also not only working on Raspberry Pi, but to other hardware which might have the security and in the hardware level.
So basically, it's kind of like, because it's building on Yocto, you have a lot of devices which are supported, and they're keeping it all. The whole kind of like build scenario is really, really modular. So you can actually go on GitHub, check out their kind of like master repo for new devices, and kind of like say, okay, I'm a manufacturer and I want my device to be supported by Resin, and so I write my board files for this, or board support package, and uploaded it there as kind of like some community gift, and then they try to integrate it into Resin. So that's another nice idea if you're kind of like trying to get your board supported onto that. That's a possibility. So I reckon I just like get into there with some demo, and they had a Christmas light demo, which I really liked. And yeah, so the basic idea is, where do you find all that stuff? Resin you can find on Resin.io. So yeah, the name's already the program. And from there on, you can kind of like see all the whole thing. The nice thing for us kind of like hackers and geeks, stuff like that, is always the pricing. So if you want to go down there and kind of like try it, the nice thing is you can get your free trial, not free trial, but free tier. So you can use up to 10 devices for free and no strings attached, which is a nice thing. So you can use it for how long you would like. So if you have kind of like some project in mind and try to roll out, you can do that. So with that said, we just like go there, and I'm logging into my session, and that's what we see when we are in there. We got our dashboard, and then we can kind of like create a new application. We got these device types, and as you can see, the list is quite long. So we got Raspberry Pi there, we got some Samsung Attic boards, we got Upbox, Zinc is already there, Parallella, even the NVIDIA Jetson boards are there, some Odroid. So it's quite interesting, and BeagleBone, yeah. So we got the interesting stuff we got already there. So I'm going to just like call my application Blinking Lights and create it as Raspberry Pi free application. After I done that, it asks me to add a device because, yeah, it wants to push some code, if I got any, to a device. So I say, yes, please, and can choose my Resin OS version. I'm sticking with the latest and greatest. And you can actually change some settings here. You can go to a development or to a production image. The development image is nice for development because you can really physically log into your local image, into your local device, and figure out with that, which kind of like eases the development process. And you can also, if you want, already include credentials for Wi-Fi login. If you kind of like want to really kind of like set up your device with flash of the SD card, plug it in, and just like throw it away into the reach of your Wi-Fi. Yeah, and from that on, you can just like download the file. So, which is kind of like, come on, you can do it. Yeah, that's getting better. So the file is now downloading, and from that moment on, we can go there and grab ourselves a micro SD card, which I did here already, and I plugged it into my PC now, which hopefully doesn't crash. Nice. And one nice thing is actually Resin also provides a nice tool which is called Etcher, which I can really recommend. It's actually really getting popular at the moment because Raspberry Pi Foundation is also recommending it for flashing devices. And it's basically for every kind of operating system. It's free, and you get a CLI only version is already in production. So it's basically one of those nice things. You just like go to your download folder, get your file there, and just open it. It tries to figure out which device it wants to write to. 16 gigabyte SD card, yeah, that's fine by me. And just like click on flash, and it's starting to do that. So, and while it's actually flashing the SD card, I reckon we can just like go to the moment, just like putting it in the background and start working on our code because, well, we want to kind of like provide something to Resin to work with. So how do we do that? Just like making a Git repo, because that's it. So we can just like go here, and I'm creating a new folder. I'm just like calling it Blinking Lights. And I prepared this little demo, which I already linked. So, and basically we got these 3 files. We got our, yeah, that's the wrong folder. That was too quick. So we got basically this app coffee, we got a Docker file template, and a package.json. It's basically a Node.js application, and it's going to kind of like blink some lights. So how does that look from a developer point of view? That's quite easy. Let's open those up here. Yes, thank you. So we got this Docker file template here, which is basically just a Docker file, the regular one we know. So I'm just starting my highlighter. And the only thing that's different is we can see here is this resin machine name node, which is kind of like is getting replaced during the build step. And it actually kind of like exchanges for the specific machine you're trying to build for. So during the build, Raspberry Pi 3 will stand here as kind of like the placeholder, and it's going to build specifically for Raspberry Pi 3 nodes Docker image from Resin, which can get on the official Docker Hub. And then it's just like going to do the normal stuff, building your file with npm, downloading the stuff with npm, and copying files, install that. And then we got this little nifty app coffee Node.js file, which basically just initiates a special driver for the LED and works with that. So that's it basically. It's nothing really special, but it's nice. So we got our stuff in here and we want to use it on Resin. So what we do, we start a new shell here and yep, it successfully flashed the file. And we start a new Git repo. So I say git init, and I say git.
So just a second, the example and the Docker file and the template and so on.
Yeah.
That is something you as a developer, as a user can do on your own, right?
Yeah, definitely. That's something just like I'm just like copying these files in here. I created that by myself. I said, okay, the Docker file should be looking like that. It's basically the normal stuff. The only thing which is here different is I call it dockerfile.template and include this special file. But I can also go there and say I do a normal Docker file and just like do my from Raspberry Pi image. So
what I was wondering is, what I didn't see is there was no description of the ARM.
You don't need that because that's included in there. That's basically that thing above here, Resin machine name. That's basically the template section which will be replaced by Raspberry Pi 3.
Okay, so there's kind of a convention in the Kubernetes space where everything, you have these x86 or ARM8, ARM7, and so on suffixes. So you don't adhere to that standard. Do I see that correctly?
No. Resin actually is quite a lot older than all that stuff. So they build on that. And they have their own kind of like standard because Resin actually is quite a long way away from Swarm and from Kubernetes because actually they killed both of them. But I'm going to talk about that a little bit later. Okay. So you're never going to be in touch with Swarm or Kubernetes on Resin, never. I try to not to spoil too much.
Okay.
So I just like copied my files in there, initialize a Git repo, and gonna git add them all, and say okay. From that moment on, I'm kind of like okay with that, and I'm going to just like commit it and say okay, that is my init, and yeah, if I'm going there, I'm now seeing okay, everything's fine. So, but that's just locally. And I want to push that to my Git repo on Resin. So how does it look? I'm trying to find somewhere where my window went. Somewhere here. Yeah, come on. Don't hide. Ah, there you are. So I got this little nice line up here, and this actually is the secret sauce I need to add here because it tells my Git repo to add it as a remote repo. So just like copy it in there and tell them git push resin master. And what this does is actually it's pushing up my source code to Resin. I actually went a little bit before that already ahead and copied my SSH key to Resin. Yep, because otherwise that wouldn't work. But after that, it should start here. Yeah, it just like copied my Git repo or pushed my Git repo. And from that moment on, Resin is already starting to build my Docker files and stuff like that. So what we will see next is it is going to inform me that it started that. And you see no image tag given for Resin Raspberry Pi 3 node. So that's where he just like copied in the name file you needed at that moment. And he starts building the project. That's just like a normal Git, just like a normal Docker build. And while he's doing that in the background, I got this thing here, which should be ready. So I'm getting my SD card out of here and try to see if I can get my video working, which is here, and put in my micro SD card into my Raspberry Pi, just like the normal stuff, add some Ethernet, and then I got my LEDs. And I'm going to kind of like try to not screw up there. So we got 5 volts, which we need from here. Then we got some ground, which is here. And we got the BCM 18, which should be kind of like, let's say, here. Okay. So I did that. And now I'm just like applying power. So the normal thing you do, and observe if something catches fire, which it doesn't do at the moment, which is kind of like good. Okay, so we got a green light, which is nice. And we see in the background, it already was kind of like successful building, and it's showing up as a unicorn because that's the stuff Resin does. So if we go back to our Resin.io session here now, we can kind of like reload the page and see what it's doing actually. And we see, oh, look, we got a new device. It's called Holy Wave. It's basically the same thing like Docker containers. It's just like naming them like funnily, giving them a UID and see, oh, it's currently online and it's actually downloading. And if we kind of like drill down to the device, we can see which OS version is running, how it is called, which supervisor is running on there, that it's downloading the file, and we actually got the possibility to activate a terminal, be it in the app container or on the host OS. So if I start there and connect to the device, I can, okay, that will be a little bit of, will take a little moment because it's kind of like downloading about 500 megabytes at the moment for my initial repo, but we are here on Resin OS bash, giving a little lslr, and yeah, basically we are on the device which is sitting next to me. And as we enabled the developer version, actually, I could go to my local IP address, which is kind of like shown here. Go there and just like plug in my device, say SSH to the device number, say root and port 2222252. And with that, I'm also on the device and can work there as well if I want to. Look a little bit of top, something like that, and see what the device is doing. So that's great if I'm kind of like trying to do something with the device on premises. And the thing I want to do is I want to do with Docker. Why is there no Docker? Hey, I thought this thing was running Docker. Yeah, it is running Docker, but it's called Balena. And what Balena is actually a special version of Docker which derived from the Moby project. And that's the thing why it doesn't run Kubernetes or Swarm, because Balena is kind of like shrink down. It's a special version especially made for embedded devices and has some superpowers. So we're going to talk about Balena in a moment after we concluded the demo, but just to give a quick up why there's always this Balena stuff running around here. That's because Balena is installed on the device. So it's actually downloading at the moment because the first download will be our largest. Why is that? Well, that's for a good reason, because Balena has some nice possibilities or special updates or powers, because Balena is, for example, capable of doing differential updates, which is a nice thing. So it can actually make a diff of 2 files, or especially 2 containers or 2 images, and just like push the change the delta of that file. And we're not talking about layers here like we're doing it on Docker. We're talking about real deltas, which improves a lot. So the first time we're really going to download these nearly 500 megabytes, which is kind of like in the process now. And as soon as this is done and we're going to push another version of that file, it will go a lot quicker. So, but just check out a little moment what we can do as well. We can go and actually do some other stuff. We can reroute the device URL if you want to kind of like work with the device over an HTTP port. We could go there and just like flash the LED. It's stupid, but you can see the green LED is now lighting up. It's kind of like useful if you got some dozens of those devices to identify which one it is. We can set environmental variables if we want. So if you kind of like might make just some slight changes to the whole code, it can inject that basically into the device. So basically the thing you do with Docker containers as well. We can apply a special device configuration. So device configuration is really kind of like the meta level over the config txt for Raspberry Pis. So you could basically change here with resin and then some special stuff like GPU memory. You could kind of like configure on that as well, and it will kind of like change that on the device file of the Raspberry Pi as well, which is nice. And it's kind of like, yeah, device specific. Yeah, you cannot change GPU memory or split on basically a chip or something like that because it doesn't support it. We got a location tracker which tries to pin down where we are. Yeah, we are a little bit down here. We are kind of like, yeah, we're basically a little bit off, but doesn't matter. And we can also enable the local development mode, which we did, purge data or shut down the device or reboot if something goes horribly wrong. We can do that as well. So it's still downloading here. I'm closing the terminal because maybe that's going to make it a little bit faster. And at the same time, I think I'm going to just like let it work here a little bit and just go to where I was. Skip a little bit over. Oh, it's going to 95%. Maybe it's actually completing any second now. Let's see if we got something there. 97. So as soon as the download is completed, it's going to spin up that container and run the application, which in theory, if everything works right and I did nothing wrong, the LEDs should light up, which they hopefully will do. And as soon as that we see that, we're going to change a little bit in the code, make it a little bit faster, and then push it again and see what happens. So you see, starting the application, started application, and that's the moment it starts actually, and we can see, I just like turn off the lights, that the LEDs are running and blinking, kind of like changing the color a little bit, going to reddish, greenish, purple, kind of like some Christmas lights. But it's a little bit slow. So we go back to our code, which we actually pushed. It's the app coffee. And I'm going to change these little files down here for another factor. I think I prepared something because I do not want to mess with the wrong parameter and see nothing happening, which happened in the past. So I'm going to change that from 32 to, yeah, let's leave it like that. And I changed that to 200. I hope this is right. I don't recall. So let's just change, yeah, save that. And then, we are here still on our device. We do not want that. We go into our Git repo again and say, what's the status? We modified something. So we just add it and commit. I say I changed something. So, okay. And now I'm going to git push resin master again. And then it's going to uplink again to Git, especially to resin. And from that moment on, it's going to be a little bit quicker because from that moment on, normally the caching also takes place there like it does on Docker. And come on, you can do it. Yes, we got one delta, that's correct. was not really huge, but I think my connection is a little bit sluggish at the moment. So basically it starts building now and tries to get the old files from the cache so that it doesn't have to repeat all the other steps which it already did some seconds ago. So we got this start building build. He's pulling the old images for caching purposes. And he's building on ARM 03 because they are really building on ARM metal, not kind of like the old files, the emulated stuff. So they get a little bit better performance to building directly on metal.
And so we see that IO in the free tier keeps a build farm for you.
Yeah.
Do you know, is that a proprietary technology, or are they using Travis, Concur CI, or something like that?
They actually, so Resin.io is kind of like the whole build setup you kind of like can buy. You basically go to Resin.io, sign up and say, okay, I got kind of like 200 devices. I want to kind of like ship my stuff. And they just like try to keep up with that. Just like keep your device running and you just like provision your code and don't care about anything. And that can be a really useful use case for a lot of corporations because they do not have to care if the device gets killed or stuff like that because that's Resin's problem. But you can use that with complete normal build chains you can build with CI stuff. So basically the Resin OS itself is free, which you can see, and you can kind of like create your own build chain, which I actually did with Drone and Gox and the Docker registry, and then you can build your own Resin IO for yourself if you want.
Okay.
So that's kind of like they're kind of like supporting that already. So, oh, did we actually miss it? Yeah, we missed it. Sorry.
But
I was talking too much.
Yeah,
yeah, it changed a lot quicker there.
Okay.
And it's already restarted the thing, but it did not have the desired effect. It's not really a lot quicker, but we can see that it started at 2025 and 2028, which is kind of like, yep, just some seconds ago, it restarted it already. So we can see that these deltas are really, really fast in downloading because it's kind of like only trying to, spit down what really kind of like changed. And that's a cool thing about it. So basically, just let me move that out of the way. To just like wrap it up a little bit, Resin OS is, as I said, the open source component, which is completely free. It's the device, it's the OS itself. And it kind of like layers here standing Docker, but through its Balena on top of all the whole stuff you got there. And you can just like use it from your local system. There's actually a component CLI tool, with which you can kind of like build locally and push the stuff onto your device if you want to, and with which you can kind of like provision the device without having a complete kind of like build chain if you want. But you can do it with open source tools. You can do it yourself if you want. That's no problem at all. And they're kind of like supportive in that way as well. But if you're kind of like a corporation, it makes sense to kind of like offload the risk to Resin, basically. But if you're kind of like a free developer like me, and that's why I'm really interested in that, it's cool because I have my about 12 IoT systems, scanners, stuff like that, which I use in the field for conventions, stuff like that, and I can just like pull my stuff into Gox, get it down there to Drone, let it build there, upload it to the Docker registry, and then my Resin OS is going to pull stuff from there, and I got all my stuff running. So that's cool.
Is that stuff, did I hear that correctly? Is that also running on the Columbus ISS?
No, sadly not. I'm actually trying to work on that, and I was talking with some guys over at Docker, at the last Docker EU conference. I was talking with some higher ups down there, which because I was kind of like joining at the job at that time, and they were just like, "Oh God, you have to bring that stuff up in space." And I was just like, hey, "Come on, keep down and can't do that." But actually, I have quite a good connection to those guys actually supporting the 2 Raspberry Pis on board of Columbus, and they didn't hear about Docker, which is kind of like nice because I was just like, you have to check that out. It's going to make your provisioning so much faster. And yeah, they're kind of like interested, but I don't think it will end up. But we can conclude that Docker is a tool which is used in a wide array of ways, also in space stuff. So.
Okay.
So it's cool.
This kind of reminds me, just in that same, we're just watching The Martian with my kid, right? And they have the the problem of updating with 20 bytes the communication module on the Sojourner, or right, if I remember correctly, or the Pathfinder. This would ease up that kind of patching very much, right?
Yeah, we actually got some stuff up there. So they had to, if the SD card were broken, and they really have to take them out and let the crew swap that. And crew time is very, very expensive, really expensive stuff. So doing something like that would kind of like really make the whole stuff a little bit better. And yeah, the uploading only deltas instead of complete SD card images. Yeah, we know these things can kind of like get zipped quite goodly, but several hundreds of megabytes uploading into space, it's not the thing you want to do, because we are not kind of like good bound to that. So it's kind of like very expensive stuff. So
okay, sorry about my questions.
No problem at all.
Okay.
So, and here we can see how the Resin OS is kind of like set up. We got the boot partition, which is read-write. And most of the stuff, like the Resin root, is read-only. We got the update partition, which kind of like changes back. We got the configuration and the data. And data is where, as we can see from the OFS, where all the Docker or Balena stuff is kind of like running. And it's basically overlay mounted. So if kind of like something gets broken, yeah, the overlay is kind of like lost, but the basic system is working. And so you can always, if you kind of like mess something up, you can go back and kind of like shove new data onto your device, and that's a cool thing. So you can always go to basically to the website of, I think it's resinos.io, and yeah, you can just like grab your Resin OS from there and start building onto that, and yeah, work with that as well, and you get it for a lot of devices as well. It's free. They also did add Siemens IoT 2000, which is nice. So we are in industry now. Yeah, and the last thing, which is the most interesting component and which is all boils down to, is Balena, because that's the product they just like launched at DockerCon Europe 2017, and that's the main component of the whole Resin now. Balena is kind of like a drop-in replacement for Docker. It does everything Docker does, except for the stuff it doesn't do. And the stuff it doesn't do is basically stuff which you do not need onto your device. So we got for the kind of like nice stuff, like that the stuff is that Balena is a lot smaller, that you got your multi-arc support for different kind of devices, that it got these nice diff updates which are kind of like really efficient, and changes in behavior, so it does not try to kind of like unzip everything to the device SD card, but tries to keep stuff in memory and stuff like that. And atomic, yeah, that's one of the interesting parts. Atomic durable image pulse. That stuff is all included in there, which is not in Docker, but it comes with the drawback that your plugin system of Docker is not included in Balena, and Swarm is completely swapped out. So you kind of have no possibility to use that. If you want to use IoT devices with Docker, kind of like Raspberry Pi and real Docker, use Docker, because Docker is now fully supporting Raspberry Pi. You can just like get your normal curl install Docker there onto your latest Raspbian, and boom, you set up and you're working. But basically, because they're trying to have a special use case here with embedded devices, it makes sense to kind of like boil out all the stuff you do not need. There are also other stuff which is not included, like the syslog, some logging, special logging stuff, or network plugins do not work, but that's not something you want to use onto an IoT device. So
the conservative memory usage you were referring to, what exactly does that mean?
Yeah, well, basically, the idea is it tries to keep more stuff in memory in terms of the one thing is have a lot of more headroom because of the fact that you have all these kind of like not used features excluded from there. So if you're kind of like talking about a Swarm instance or even more about Kubernetes activated, if I would kind of like try to start Kubernetes and Swarm onto my 1 GB Raspberry Pi, I reckon nothing will kind of like do anything anymore for quite some time because it will be swapping like hell. And if you kind of like exclude that from your Docker file, it boils down to the bare minimum. And so basically, the file itself is a single binary and it's only some megabytes in size. And it's completely packed into one file. You do not get the problem of it's trying to grabbing data again from the SD card and reloading, but it kind of like loads into memory and it stays there. And it kind of like can use it in that way a little bit more efficient by cutting out stuff it doesn't need and trying to, try to do these atomic and durable image pulls so that you can, and the extraction of the layers is a little bit better in terms of that it doesn't try to kind of like write partial stuff onto the SD card, but try to cache more at that moment, and then writing it as whole chunks so that it gets it organized a little bit better. That's the idea behind that. And yeah, these image deltas you can create really easily. So you using Balena like you would use Docker. That's the nice thing about it. So if you go to your device, log into there, you can just like go there, Balena, and say Balena version, and it will come up like your normal Docker. And you reckon that the server is actually trying to mimic the name scheme of Docker, and they try to keep Balena up to date with Docker. So if kind of like Docker improves, Balena should improve as well, which is nice, except for the features which are cut out. So, and if you're going there for kind of like Balena help, it will pull out all that stuff here. And a lot of that stuff will be kind of like really interesting and similar to the normal stuff you see there. And then you can go there for, let's see, I'm going to Docker. It's so horrible. So if you go there, you should actually stumble across, I don't see it. Where do I get it? Not images, image. If you go to image, you got this nice delta command. And that's basically the thing you would need. You can kind of like give the delta command two images, your source image and your destination image, and then you can create the delta file from that. And that thing you can actually use for updating. So basically, it's just like that. You just like pull your Node 6 image and maybe your Node 7 image. And then you create your delta between the Node 6 and the Node 7 image, which is kind of like the difference then between updating from 6 to 7.
Does Resin work with the OCI specification to bring these kinds of interesting use cases into a standard spec? Do you know about that?
Balena especially is a spin-off of the Moby project. So they're really working closely with Moby. So it could be that they're kind of like trying to push that back, but I don't know. At the moment, it's kind of like some really specific stuff, but I kind of like hope that they're kind of like pushing that back to the real branch, because that would help Docker so much, or the whole community will benefit so much from that. So, but I don't know how it is working. I hope. So with this image command, I thought you kind of like building your delta image. You can tag it. So you're getting an image ID and you tag that image ID, and you can push that. And if you push that onto kind of like your registry, you can push it to Docker Hub, no problems. You can just like delete your old your delta image on your device and the Node 7 image, because you want to try to test it, and just like leave the Node 6 because that's the base, and we want to update base 6 to Node 7. So the next thing you do is just like doing a pull from a delta 6 to 7, and it will automatically kind of like upgrade it to Node 7. So automatically upgrade means following. If you would start with your delta 6.7 image now and spin up a new container, you would end up with a Node 7 container. It would not say that it's Node 7, but if you would try to make a pull of the Node 7 container from the Resin hub, it won't download anything, because it will say all my layers are there, and it will practically integrate your differential upgrade into your with your Node 6 to your Node 7 image in the background, which is really nice. So you do not kind of like have to kind of like pull anything together. You just like pull your diff file from your repo and you're done. And that's the nice thing. And you can do it on your device. You can do try to do that in your build chain as well, because that's the nice thing. It's available for everything. You got that for Arch64, ARM5, 6, 7, and also for your 64-bit machine. So if you want, you can just like grab that little install here, like you do it with Docker, and just like throw it into your next VMware machine or stuff like that, virtual machine, and play around with that, because that's basically what Balena is all about. It's open source as well. So you can go there to, I think it's balena.io. I hope, yeah, it is. And kind of like go to download and just like download your file if you want, or you can go to GitHub and work with them. So if you kind of like go there for your ARM v7 file, especially download that file, you will see it is about 7 megabytes zipped. And the nice thing is, if you kind of like open that thing up, okay, you got your 20 megabyte Balena file, and the rest of these are symlinks, which are pointing to Balena to have the different kind of stuff stated, because everything's included. So your RNC, Balena D, your proxy, everything's included in there. You got just like this single file which you run and it works. And yeah, that's the awesome thing about Balena. So yeah, so we saw how the whole thing works together. The basic building part is Balena, because that's kind of like the engine on everything runs. Everything is bundled in the Resin OS, which makes the whole system kind of like yeah, failure proof in terms of just kind of like defective applications you load onto there, transfer errors, stuff like that. And then you get Resin.io on top of all of that to kind of like give it a nice management overview, work with that, restart, get your device, and kind of like brick your device if you want it and get it back to a nominal state. Or, which you can do as well, you can also update your Resin device in the field, not only the application, but the supervisor as well. Otherwise, it wouldn't be funny. So yeah, if you got any questions, hit me. Oh, I actually would have to, where is my chat window? Somewhere.
So this is a call for everyone. I think, again, virtual applause from everyone to this very nice demonstration. Actually, what I'm going to do is, the next thing is I'm going to create me a free tier on resin.io and buy another Raspberry Pi, and I'm going to try this out. This is very interesting for my hobby as well.
It's definitely interesting. If you want another, I actually did 2 additional talks on Resin.io and Resin OS, which are a little bit aged now. But if you kind of like want to check them out, they're actually on my website under videos linked with all the files and some demos. So yeah, we got here the Resin OS and the Resin.io. So, okay. And with presentation and example materials. So if you kind of like want to chew on that a little bit, you can do that.
That is from your website, right?
Nico, yeah, from Nico Maas.
Oh, perfect.
Yeah. So basically, if there are any questions as well as that, the cool thing about Resin is really community driven, and that is basically, I'm just a fan. I just like stumbled upon them. I found the idea was really cool. I met with them up at DockerCon, and I'm doing a lot of stuff with Resin. And the cool thing is, you can kind of like do with the power of Docker, you can do nearly everything. So the cool thing is, actually, I had that thing running with let's see if I can find that up. Got that thing. Yeah, that was the first try of Balena doing the flight to DockerCon. Okay. But the nice thing is, you can kind of like do everything with that. So you can basically go there and write an application which uses a GUI. So I actually got here my Resin device, my Raspberry Pi running there, and having a calculator running on that thing with a GUI, output it over HDMI, and I can use my keyboard and my mouse and input data there. I got also a little device sitting next to my table, which got a touch screen, which you can work on that, or use I2C bus systems or stuff like that with that. And everything included in Balena in your Docker container. And it's kind of like really cool because you can really work with the hardware if you want.
Okay. And you're Nico, you're just a normal user. Have you done pull requests and fixes in resin.io?
Actually, I didn't do that much in development stuff with there because the problem is I'm having not enough time because I'm having a really big project which I'm supporting now for. It's going to be 8 years now, so it's kind of like my child, and it's a really big project for management of conventions, stuff like that, and projects about a little bit more than 80,000 lines of code, and I'm the only supporter of that thing. And it got basic hardware which was created just now, or the second time it was created for checking tickets in entrance and stuff like that, and a lot of special purpose-built applications and appliances, hardware as well as applications for mobile phones and stuff like that. So it's a really huge project, and that kind of like nips away all the time I have left besides my job. So I cannot do as much there, but I'm referred to internally in Resin as kind of like the power user. And as I kind of like got to know upon calling this presentation, they are now starting with an ambassador program, and they were just like, yeah, you're going to be a founding ambassador. I'm just like, what? Okay, nice, like you. So yeah, I'm kind of like involved.
That's really interesting, Nico. I actually also have some Raspberry Pis. I'm gonna try it myself as well.
Cool.
Yeah, and if you would like to share the presentation with us, later, I think you've been presenting. I know you're using HTML here, but can you PDF that thing and
sure.
Yeah, that would be great to share it with the others as well, or you can upload it to the website and provide the link. Whatever is good for you.
Sure, no problem at all.
Yeah, cool. So thank you very much, Nico, for the talk. Does anyone else have any questions to Nico? And Nico, we can see you as well. So. All right, I guess with that then, yeah, thank you very much. I'd like to thank our speaker, also Torin, for giving his talk, and thank Pavel and Vasu for co-organizing from the Kubernetes side. We will have our Slack channel. We will post it on the Meetup comments. Also, don't forget our YouTube channel and Twitter accounts, Docker Heidelberg Twitter account, and Kubernetes Rhein-Neckar Twitter account. And if you have any questions, just shoot. So thank you, everyone. And with that, I will conclude the meetup.
Thank you very much.
Thank you,
Have
everyone.
a nice night.
Thank you. Nice. Bye-bye.
Bye.